How's it going? Let me just move this over here. Can you hear me all right? Let me move this around a little bit. Tell me if the music is too loud. So, I've done quite a bit since the last stream, so let me just, I guess, go through that really quick for my own edification, if nothing else. How's it going, Saucy Pup? Give me 1 second here. Okay, so this is messed up. I need to fix this. But basically, so last stream I was working on a pushing and pulling mechanic, and that works pretty well. I guess the first thing that I changed is I changed the player sprite. I replaced him with this guy who, it's a big sprite sheet that I drew last year when I was prototyping some of these mechanics. For two reasons basically. One is that I just already had all these, sprite frames drawn, so that's going to make it easier to prototype things with some visual representation. But the other reason being that this guy fits into a 16 by 16 square, which I think after playing around with the cowboy that I drew, he was sort of like a 24 by 20 sprite, which I didn't mind. That's fine even using a 16 by 16 tile system because I have full range of movement here, so it's not really an issue. But it did sort of bring to my attention the issue with size relationships, especially as I was dealing with the pushing. So I think it's just going to be a lot easier to keep that simpler and down to a 16 by 16 square. So that's what I'm doing. Anyway, yeah, so I've got this pushing mechanic. Right now it's working on half tiles. So he just moves at 8 pixels. And that all seems to be working pretty well. And I've also, I've put that into a component actually. So now anytime I want to, if I want to be able to pull the trees, for example, I can just pop on this push-pull component, and that tree I will be able to pull. So this one I can't, and this one, wait. Maybe I have to do it in this, not in the instance. Actually, I haven't tested this yet, so theoretically it should work. Let's see if I do that. Push-pull component. Let's see if that works. It still doesn't work. I wonder why. Okay, in any case, that's curious. I wonder why that is the case. Theoretically, it should just do that. So I'm not sure what's different here. Okay, Okay, I don't need to worry about that, but I will make a note of that. The second part of sort of object interactions that I'm working on is picking up things and carrying them. So the animations are a bit borked right now, but it still works pretty well. Just that pickup animation is a little weird, but otherwise it's doing what it's supposed to do. And basically all I'm doing there is you know, if it's the type of object that can be carried and thrown, then I'm going through all of this math to sort of calculate, you know, if I'm picking it up from left and right, then I'm just creating this arc so that it looks kind of nice. And if I'm facing up and down, then it's just a straight up lerp. And then that turns me to the carry state. So that's working pretty well. I also sort of cleaned up my code a little bit and factored out some functions because I'll probably use them again. I also changed the animation state machine, so I'm basically just calling things directly from code now, which I think is a little bit simpler. It just means less stuff written here, especially as this gets more complicated. This music is a little bit intense right now. That's nice. Oh, number 1. Okay, so let's see where we're at. Oh, another thing I did is I created a secondary scene. Oh yeah, also I created these little slime guys. They just basically have a kind of random movement right now. It just gives a little more life to the scene for the moment. I'm gonna get more in depth with what I'm doing with them later. But for now, they're just kind of sliming around, so that's nice. It also helps me make sure that all the physics are, you know, physics and movement aren't doing anything weird. All the collisions are working properly, so that's all good. And this, you know, this checks, so if I want to push and they're in the way, it's not going to let me push. I still do need to put in some code that will, right now there could still potentially be a problem if I push and then once I start pushing they actually move into the space. Theoretically that could cause a problem because the pushing movement isn't actually being handled by the physics system. I'm sort of directly changing the position. So potentially there could be some problems there, and the way I'm gonna, that was a little weird. The way I'm going to fix that is to send a signal out once the push or pull starts happening that basically tells the enemies not to move there. But that I'm going to leave until I start actually messing around with the AI system, which I have not built yet. So that's going to come much later. But the other thing I did was I just built this little pool table scene just to mess around with the physics and play around with things. There isn't really much point to this except just to kind of play around with objects and see how it works. And as I get some more abilities tied to the character, then I can experiment with things and see what happens. So the main thing that I want to do now is I have this carrying system, but I don't have the throw. And so I took some notes for what I want to do there. So a few things need to happen. So the first thing is I need to check if I can throw. So there's going to be cases where you just can't throw. If you're next to a wall, for example. And I think the simpler way to deal with that is just to not allow you to throw. There is a possibility, you know, if you throw against the wall, then it sort of ricochets off and lands somewhere else. There's different ways to do it. I think it's simpler to just make it so that you can't throw, because if you're throwing against the wall, that's kind of on you. So I'm fine with not allowing the player to do anything there. So there's two things that need to happen there. The landing position, I think, is just going to be a simple... it's going to be a static distance away from the player, probably like 2 tiles, something like that. Maybe a tile and a half. It doesn't need to be very far. There are going to be other abilities that the player has that manipulate objects, so this is just the sort of very basic stuff. So it's probably not going to be used that much. But so I need to check that position, or I need to calculate that position first, which is fine. That's pretty easy. Then I'm going to need to do 2 checks, actually. So obviously I need to check if the position is clear to see if I can throw there. But first I need to check what's in between here and the landing position, because there may be objects that you can throw over but you can't throw on. So for example, like a gate, you couldn't throw if the gate was on the landing position. You can't throw there, but if it's, let's say, the tile in between, you should be able to throw over it. And then there will be objects which you can neither throw past nor throw on, like a wall. So basically I need to check for both of those things. So first I do the raycast to check if there's something like a gate there, or rather what I'm checking for is if there's like a wall there, if I can't throw past anything, because if I can't throw past anything, it's not worth it to check for anything else. And then if I can throw past something, then I need to check the position. And then, if that's all good, then we start the throwing. So basically, I'm just going to be doing the opposite of the pickup, of what I'm doing to pick up right now. I do want to do something here, this may happen later, to instantiate some kind of shadow, because right now, I think it's fine for the picking up. But basically, you know, when you pick something up, okay, now I'm carrying it over my head. When I throw it, it's going to be traveling, it's going to be traveling a certain distance. And because of the perspective, you know, it's going to look a little weird unless you have some sense of 3 dimensions there. So I think I need to instantiate some kind of animation, some kind of shadow underneath it, you know, something that would start small and then get bigger as it's getting to the landing area, just to give you a sense of how high up it is. So that's one thing. I don't need to do that immediately, but that'll happen somewhere in this function. And then I'll do this reverse stuff, whatever I'm doing for picking up, I'll do the reverse of that. And then the idea would be, once it actually lands, we want some sense of momentum. We don't want it to just stop in place. So we want some sense of momentum, and that I think can just be that can be factored out to the object itself. So that doesn't need to happen inside this throw function. We can pass in like the velocity, although since you're throwing it at set distance, it's always going to be the same velocity, I think. But that'll be handled by the object itself. That will use the built-in physics. Although one thing that I do need to make that really nice, we want to check the tile type. So right now I'm just kind of using this basic sort of sand tiles, which, you know, there's nothing happening there. I haven't messed around with the tiles yet. But for example, if there were some ice tiles, right? Theoretically, when you throw something down on ice, it should slide a lot more than if you throw it down on sand. And maybe the type of thing that you're throwing would affect that as well. So if you throw, you know, a shiny ball versus like something spiky is probably just going to land and not move. So a shiny ball is going to move more. So that I'm going to have to handle in various like physics materials and stuff, which is also why I made this pool table scene to kind of test things out. But that's all going to be within the objects themselves. We don't need to do that within the player. So I'm going to start building that out. Now, one question is whether I need to make the throw a separate state or not. My inclination is yes, because I'm going to have to handle stuff like what happens when you get hit by an enemy, let's say, while you're carrying an object. You drop it, in which case this is going to, even though it's not much code right now, it's going to it's going to get a lot more complicated. So just for cleanliness, probably better to make that into a separate state. So we'll put the check in here to see if you can throw before transitioning to that state. So the first will be, we're going to check the we're going to check the right bumper. That's going to be our button to throw. So basically the left bumper, this is also something that I changed in between last stream, is I decided to eventually get 2 bumpers, to add another button to this whole push pull carry throw thing, because it's just going to be more intuitive that way, I think. So kind of an intuitive thing. Left bumper is how you pull, right bumper is how you push, and then that also applies to carry and throw. So left bumper is how you pick something up, right bumper is how you throw it. So there's sort of a sense of, you know, bringing something to yourself versus pushing it away. I think that will be intuitive for people. So we're first going to check if we get the input, and if we do, we're going to calculate the distance, or we're going to calculate the position of where we're throwing to. So that is going to be a variable here. We're putting all of this stuff together, I guess. That's fine. And let's say this is 2 tiles, so that would be 32. So we will create a variable which is throw position. I think I'm using pause in other places, so we'll just call it that. Throw pause is going to be we want to take the global position of the player. Oops, we do need an equal sign here. Global position plus, then we need to take the direction that we're facing. So, face direction. Also another thing is we need to actually put in the face direction setting code into the carry state. Which is where? Here we go. So we need to put that into any state where we can actually change direction. And that would be carry state. We'll put that first. How are we doing it up here? Set the velocity. That's fine. I wonder what the best, it probably doesn't really matter, but I wonder what the best practice is in terms of the order to put these things in. So up in the normal state, I'm calculating all the movement stuff before looking for the state changes. But I wonder if it's better to do that at the end. I'm going to move this down to the end, I think. Although, yeah, see, we want to get this face direction first. So actually, no, okay, we'll make this consistent and do that everywhere. Get it to face direction first, because that's a really important thing. So we'll do this, oh, I already have it in here. Okay. Okay. So this is exactly like the normal state. Yeah, that's better to just keep it consistent. Okay, so now we're going to take in the face direction, and we need to multiply that by what was it, the throw distance. And that's going to return a vector that we're going to check. And the way I'm doing this, I'm not actually normalizing it to the tiles. And I'm not sure if I should do that, but I feel like something like throwing an object, it's going to feel better if you have a lot of control over it, if there's a lot of fidelity in how you throw it, as opposed to pushing and pulling, which is going to be, that's going to be more sort of structured puzzles, but throwing something, that's going to be more kind of part of the basic, expressive abilities that you have. So I feel like it's better, like just walking around, it's going to be better to not have that locked to tiles. That may cause problems, but I guess I'll deal with that as they come up. So we calculate the throw position, then we want to do a ray cast. Now, I should probably factor this out so that I can use this ray for different purposes. Because there's probably going to be other situations rather than just putting another raycast in there and creating a new function. So let's create a Boolean variable here, and that's going to be object is, let's see, we'll call it wall. Object is wall. Basically, this needs to account for any kind of object that we cannot throw past. Not just throw on, but throw past. So it would be a sort of hard boundary. So that would include walls, but it might include other things. I think we'll call it object as wall is fine for now. Okay, so that's our Boolean there. So this detect objects, I think what we want to do here is, this is fine. We want to match the face direction, but we want to change the length for various things. So right now this is set directly to the detection for picking and pulling up objects, which is 2 pixels beyond the player's collision shape. So we want to actually check a lot more than that. We want to check a full tile. So we need to factor this out. So let's create a variable up here. And we'll call it, actually, where's array stuff? Is there anything else? Detected object, that's up here. I'm going to have to clean this up. This is too many things in the same place. Variable push pull. That's also going to count for carrying things, but that's fine. Push pull ray bounds. What's the right term for this? Because it's got to be different according to, it's not going to be a square, so they're not going to be even, right? So because the player's collider is a ellipse, so it's got to go further out when it's horizontal versus vertical. We'll just call it lengths, and we'll turn that into a vector 2, which will be 7 and 5. And then what we want for, now actually, I don't expect to change the player's collision, but theoretically we should just, actually theoretically the ray should start from the edge of the bounds rather than from the player's transform position. But also if I wanted to change the collision shape at any point, then that it would be different. I'll just make a note of that in this script. But for now, let's see, throw ray lengths, and this is going to be let's just make a note here of what the player's collider actually is. So it's, wait, 10? Oh, because it's a capsule. So what exactly, how many pixels is that? So it's 1, 2, 3 tall, 1, 2, 3, 4, 5 wide. Right. So capsule collider is 5, 3. So if I need to change that later, then I just have that note. That's kind of nice. So now we want to check a whole tile, do we need more than that? Yeah, if we're throwing it 2 tiles, I guess we could also factor this out so that we could change it later so that it takes in this constant, but that's fine. We'll just do it directly for now. So a whole tile plus the distance of the actual collider. So 16 plus 5 is 21, and 16 plus 3 is 19. So down here, now that we have that, this is going to take in a variable called ray lengths. And when we call it up here, we're going to pass in, what was it? Push-pull ray lengths. So push-pull ray lengths. And when we call it down in, where was it? Oh, we haven't called it yet, so we'll do that. So we take in ray lengths, and basically we just want to get rid of that note. So ray lengths dot x, but we want to make it negative. And this is just going to be the normal one. And then we'll do the same thing here. And make that negative. Great, so now that's factored out. And now this is where we're going to get our information. So we're basically, it's probably a cleaner way to do this, but we're just going to add in another condition here. Detected object dot has node you know, I could probably do this with like collision layers or something, but this is just consistent, so it's better. And we'll call it a wall component. I'm not sure about what sort of things might be applied here that aren't walls. I mean, like a big rock, let's say a rock like this, should you be able to throw an object over that? That's sort of debatable. So I'm not sure. I'm not sure if I want that. And if I call that a wall, that's kind of weird. But maybe that's clear enough. Okay, that's fine for now. We just have to create a component to fit that. Then we're going to set these things to false. And then we're going to set, and also I'm going to do false first and then true second. So then we need to create a object is wall equals false, and we'll copy that and put it here as well. And then here we're going to set it to true. And here we'll set it to false. Okay. Yeah, there's going to be I guess I could do like a match statement there or something, but this is fine. If I start using this function for other things, then I might need to clean this up. But for now, that's fine. So in the carry state, let's just create that component before we forget. So components, where are we? There we go. Let's create a new scene and we'll call it wall component. That is what I called it, right? Wall component, okay. And the wall component, well, right now we don't actually need anything to happen in there. We just need to attach it to something. So let's apply it to the movable stone. That brings up an interesting issue, because the way I'm doing it now, you can't be movable and also a wall. So I wonder if that's a good idea or a bad idea. If you can push something, should you be able to throw something over it? It feels sort of intuitive, but it kind of depends on how it's represented. See, like these rocks, the way they're shaded, they look sort of tall. That looks like as tall as the player. If this is a 5.5 foot tall kid or something, the rock is at least 5 feet. So should you be able to throw something over that? That looks like you should be able to throw it over it. The problem will be how it actually looks. So if the throw distance is directly the next tile, then it's going to cross over that. I could always make the arc wider. That's weird. Slime is sliming me around. I guess there's only one way to check, which is to test it. So right now, I'm not going to attach it to the movable stone. I'll have it so you can throw over it, but I will attach it to, let's say, the cactus. So let's add that. We have a wall component now. Okay. And yeah, we can just go over there and test that out. Okay, so back to the script. We'll get to that later. Okay, so now we're going to check if we've got this wall component. So how do we do that? We've got the throw distance, and now we want to detect objects. If detect objects, and we're going to pass in the, what was it? Throw ray lengths. Actually, we don't need to check if we're detecting objects. We just want to check it. So detect objects, and then do we need to wait at all? Is that being done in the detect function? No, we're forcing the raycast to update. So this should all process before the next line. Oh, and detect objects returns a bool. That's good to know. So how are we doing it up here? In the normal state, if detect objects, well, that's because we don't want to grab or try to push anything that's not there. With the carry function, with the carry state, if we're pressing down, we do want to check if there's, something there. So we're doing the opposite. We're doing a negative check. We only want to do things if we don't get this. Detect objects, but detect objects is going to set this. All we need to check for is object is wall. Or actually what we want to check is if object is not wall. We'll just say is false. Then what do we want? Right, and if this is false, or if there is a wall, then we just cancel out of this. If there isn't one, then the next thing we want to do is actually check the landing position. So there, we're going to use the check area clear. It may be useful eventually to check, to factor this out. Right now I'm directly setting it to a 16 by 16 tile, but it may be useful. This is probably a pretty useful function, so I may need to factor that out, but I won't do that until I have to. No need to get ahead of myself. So all we need to do is factor in the pass in the position. So we're going to do, and that also returns a bool. Is that correct? Yes. So then we just check if, what is it called? Clear. I forgot the name of the function. Check area clear. Check area clear, and we want to pass in the throw position. And then we're going to, one thing which I think is probably a good habit to get into right now is to have some kind of list. Oh, Yeah, this is okay. This is actually really useful to have this list here. That's nice. That's nice and convenient. Okay, so then I can just look there. Okay, so if check area clear. So if it's not, then we cancel, we don't do anything. If it is, then we want to actually throw. And so that's going to be basically the reverse of our picking up. So we're going to... this is a problem. Right now in the pull and push state, we're setting this variable detected object. And once we're in the carry state, we actually want to do another detection, so that's going to replace the detected object. So then we don't have a reference to the object that we're holding. That's an issue. So as soon as we're done, so as far as pushing and pulling goes, it doesn't really matter because it's just doing one detection. But really, we should be, as soon as we're done with some kind of state, we should be changing that. We should be referencing something else. So let's do a variable carried object, and then we can just sort of flip those around. So let's see. So this is where we're going to the so here we're going to say carried object equals detected object, and detected object equals null. That way, and this is only going to run once, so that way we can just kind of clear the detected object so that we can put in something else and we won't lose a reference to it. So if check area clear, we want to start throwing. So let's go back to our picking up code. Let's just copy this and paste it in and see. This all needs to be, oops, this all needs to be a tab out. Oops. Oops. It should be if it is equal to. Yeah, so we need to set this up. I don't think there's. I think right now we can actually change all of these arc things to just generic. Let's just make sure they're, yeah, I think we can just get rid of the pickup identifier there. So we'll just call it arc radius. And let's just go and search through them. That's within a function. that should be fine. And then we'll call this arc center. And that's being used a lot, but it's all within this function. And that's not going to affect anything. And then we can just reuse these for anytime we're doing some kind of arc calculation. Okay. Okay. Pick up angle increment. Where is that being used? Oh, I'm not using that at all. We can just delete that. Great. Okay, so right now we can actually just put these, I don't know. We'll just put these up here so we know they're just sort of generics. Just want to clean this up a little bit. Okay, and eventually I'll probably move these around so that I can export them and play around them as I balance things. But that's fine for now. So back down to here. So, okay, if this is going to be the start throwing. So now we want a bool to see if we're in the process of throwing. So let's add that up here. There is throwing equals false. So this will run the first time, and then not after that, because we're gonna set it here. So we want to check all this stuff. No, so actually what we want to do, yeah, this is the reason that we need to factor out the actual throw logic into a separate state, is because we want to use the lock direction, because we don't want to affect the calculation for how you're throwing things. Once you've pressed the button to throw, we don't want that to be affected by the movement input. If you suddenly start looking up, that shouldn't affect how you're throwing it. Once you press the button to throw, it should just throw. It's one action. So we need to actually put all this into a throw state. So let's move this. And we'll fix that in a minute. If check area clear, we're going to first set locked direction to base direction. And that's basically just a way to save the direction that we're facing at the moment that we enter this new state. And we're going to add in a switch state to player states dot throw. Do we need to do anything else there? I don't think so. And then we'll return. We don't really need that because that's happening at the end, but I'm just getting into the habit of putting a return statement at the end of the switch state. Anything else that we need here? So theoretically this should bring us to the new throw state. If object is wall is equal to false, so if there's no wall in the way, and if the place that we're throwing to is clear, we're going to save the direction that we're facing, and we're going to switch states to the throw state. So now we're going to handle all the throwing logic in this throw state. So first, okay, so first what's happening, this is when we're committed to the throw now. So if we haven't changed this variable, then this is what needs to happen. We need to set up all this stuff. So this we were doing in the carrying state so that it would render over the player, basically over top everything, because that should be the front and center. We don't need to do any of that because it's already done. So we're going to need to do the opposite of that at the very end, but we're doing everything in reverse order, so we don't need to do that yet. Then we want to check if we're throwing on the horizontal or the vertical, because if we're throwing vertically, then we're just going to do a straight line calculation. If we're doing horizontal, then we need to do all this arc stuff. So arc center equals detected object.global position. So we want the carried object.global position plus the throw position. So now we're not setting, because we're setting the throw position up here, so we should actually factor that out. I guess we can just do the calculation again. That's fine. Where was that? Carry state. We'll do this here, carry throw position. We'll do the locked direction because that's what we're using. Okay, so now we have the throw position, and we're dividing that by 2, so we're finding the center of the arc. Variable direction equals throw position, oops, I can't spell, throw position minus carried object dot global position dot normalized. So that's the direction between the two points. So we're looking at, if I'm carrying one of these stones, I want to throw it there. So right now it's there, so we're taking the midpoint and we're also getting the distance between the two. Okay, then the perpendicular is going to be the direction rotated by pi divided by 2, so that we get the basically the normal of that line that we've just drawn. If locked direction dot x is greater than 0, in other words, if we're facing right, then we want perpendicular to be negative so that the angle is different. Because if we're facing right, then it's going to be a different angle. Okay, then arc center plus equals perpendicular times direction dot length times 0.5. Oh, that's right. I'm just sort of setting this to a value there. Part of the problem is that I had with the picking up is depending on where the player was in relation to the object. You know, if the player is above, or the player might be above or below the object in terms of the player's y position, which means that when you actually do the arc calculation, it may be shorter to traverse underhand than overhand. It may be shorter to go, you know, counterclockwise than clockwise. So, but you don't want to pick up an object by like grabbing it under you. You want to always have the object be picked up over. And similarly, the throw is always going to be over. So that's basically what this is doing. Arc radius equals detected object dot global. We want the carried object dot global position. Distance to arc center. Start angle equals carried object minus arc center dot angle. End angle equals throw position minus arc center dot angle. I'm not totally remembering what all of this is doing, and I might be getting something wrong here because we're going in reverse, but I guess I'll find out. Current angle equals start angle. Oh yeah, because we want to switch the start angle and end angle. Because we're starting from where... No, actually, hold on. Minus arc center. We're still starting with the carried object. Right? The movement is starting... it's just too much math for me. I can't completely think about this. I guess I'll just test it out and find out. But let's add in the next part. So... currently picking up object. So this is going to govern... Oops. And this is going to be... So basically all of this is going to run once at the very beginning, and then it's going to set this boolean to true, so then the next frame it's going to bypass this and go on to this section. So now that we've done this calculation, and this is only calculating the arc if we're actually facing left or right. If it's not, then we don't need to deal with any of that. So if carried object dot global position dot distance to throw position is less than or equal to 0.1. I could probably make that bigger because 0.1 is quite small given the pixel size that we're working with. Whatever, that'll be fine. I can fix that later. Detected object dot global position. Oh, we want the carried object equals throw position. So this is basically just to make sure that we don't get into a situation where we're sort of continuously basically dividing by 0, like just tweaking, getting smaller and smaller motions until it bypasses the until it reaches like Godot's own threshold for comparing floats. So just if we get to a small enough distance, then we're just going to teleport it right there so that we don't have to deal with that. We're going to make is throwing false because we're done. We're checking if we're done first before actually doing the calculation. So is throwing false now. We want to reparent it to something else. We want to, first of all, it's going to be the carried object. We want to reparent it to self.getParent because the player is going to be on the entities layer, so we just want to put it back on that layer. We don't need to deal with that. And then we're going to switch state to the normal state. Now, there has to be more happening here. So for one, send a signal to object to respond to being thrown, so that it doesn't just stop. It's going to actually move in like it's going to have some momentum from the throw. Do we need to do anything else here? Oh, we also need to do the reverse of, where was that? Of this. So let's, we'll just go back, -1. And we need to change all this to carried object. Collision layer. Right, so that was sort of a messy way to deal with this, because basically as we're picking up and throwing, we actually don't want to use the collision, the built-in collision. We want to bypass that and kind of do our own checks so that it's cleaner. So then the problem is, how do I know what collision layer it's supposed to be on? Is there a way to get the... because this is going to be an instance of a scene. Is there a way to get the value of that, of the scene, even though we're messing with the instance? This seems like a question for ChatGPT. can save the original collision layer and mask values before you set them to 0. Huh. I suppose so. No. God damn it, ChatGPT. Collision layer. Oh, so that's a value. Okay. That would be a nice feature if I could access that data. Because theoretically, there's no reason that I shouldn't be able to, right? Like all of these, all of these rocks are instances of something that I have saved in here. So the value, if I start messing around with the rock's transform position, the rock's collision, anything like this, I can change all these values, and that won't affect the values in the actual scene here. So I should be able to access this. This exists somewhere. There should be a way to access that. Okay, I guess I'll do it how ChatGPT says. We'll put it. Oh, this is nice. Detected object, carried object. Let's just put it right here. We'll call it so when we pick something up, right here, equals detected object dot collision layer. Can I just access that directly? It's a property of a grid map. I just want this. Collision object 2D. So do I have to... Oh, collision object just applies to... Okay. I think I can just do it this way. Default collision mask equals detected object dot collision mask. So then we're just going to reset that down here. carried object dot collision layer equals what was it? Default collision layer and default collision mask. Okay, so that for the moment should be fine. Now I also will want to add in this this shadow. The question is where to add that in. This is where we're actually going to be doing the movement, so I'm just going to write in here delete shadow, and here I'm going to write in add shadow. I'm not sure exactly what I'm going to do there. I may look into like shaders because I really don't know how that works in Godot, but that's a possibility. Okay, so we've got weight, pickup speed. We want a throw speed. Let's just look at if we need any other variables here. We've got pickup speed, current angle, end angle, weight, arc position. Yeah, so we just want a different variable there. Throw speed equals, let's make it twice the pickup speed for now. So this is going to be throw speed. Huh? Why am I not getting a? I should be getting IntelliSense there. Why is that not giving me a? Okay, weird. Oh, I see, because it's not typecast. Okay. If is axis horizontal, right, so if we're facing left or right, then we're going to do this angle calculation. And we want to change this to the carried object. Right, okay. And we want to lerp to the throw position. That's just the straight line calculation if we're throwing up or down. So theoretically, this should work now. Okay, interesting. It's unexpected. Oh. Huh. Invalid access to property or key global position on a base object of type nil. So two things happened there. One was the arc did not work properly. It was creating an arc, but it went underhand, so I need to fix that. The other was the object disappeared. My suspicion is it has to do with the reparenting. Which I think may reset the transform. So I wonder if I just move this down there, if that solves that issue. No. Has it moved somewhere else in this scene? And the other problem is, no, so that's also disappearing. But for some reason when I do this vertically, it doesn't work. Oh, we don't want detected object. We want carried object. That's why that was coming in. That's fine. Okay, so that should work, but why is it disappearing? That's very strange. Let's just see if it actually exists. So, in our let's do a little, we'll just add it here. This is fine. So, we create a little for loop. Self.getParent. And we'll do for I in layer.getChildren. Name equals layer.getChild I dot name. Oh, what? Should be int, but is node. Oh, I just need I.name. I don't need to call it again. And then I'll just print out that name. Right, I think that should work. I just want to get all the lists of things in this layer. So it should be returning everything. So now this one is, let's just check what the name of this rock is. Rock 005. So we'll make sure that we've got rock 005 there. Okay. So rock 005 8. Ah, interesting. So it's adding it back in with a new number, continuing off from the pattern that I have here. That's interesting. You know, instead of, just to make this clearer, let's do a little debug thing here. So what's a good key to put this to? UI enter. UI text completion accept. Let's do insert. UI text toggle insert mode. Okay. If input dot is action just pressed, UI text, what was it? UI text something insert mode. Toggle insert mode. Then let's go here, and we're gonna, oops, we're just gonna put this code in there so that we don't run it every frame. Why is it still giving me duplicates though? They're all called the same thing. Huh. That's odd. Why are they all called the same thing? Is name not the right thing? Node, no. Get name? Node path. Get name. Returns the node name indicated by IDX starting from 0. So sprite path. No, that's not going to be the actual node in the scene, though. Ion layer dot get children. This isn't actually going to be a representation of the object, is it? I wonder why it does that. Maybe name doesn't return what I think it returns. Name, I need a property. So what is the name property? The name of the node. We try get name. No, it still does that. It's returning the right number, which is, I suppose, all I really care about. Is that correct? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. There's 2 rocks. Oh, because it's returning the movable rocks also as rock 008. Why is that? That's so odd. That's such an odd... Oh. Why are they also called rock? That's strange. So those should be different though. Rock 006 should be movable stone 001. And rock 007 should be full stone 02. Then let's also get rid of some of these so that it's just clearer. So let's have just 2 rocks in the scene. Then we can test. Okay, so now, yeah, I don't know, it like generates a new version. That's very strange for each one. But at least we can test that. So now let's see what happens once we pick something up and throw it. It disappears. See, there it is at the bottom. Right, which should happen actually, because we're adding it to this the layer again. Oh, you know, it's probably here. Yeah. Oh, it totally is there. Yeah, okay. The problem is the Z layer. So it's actually working fine. So the problem is here. Equals Z index. What happens if I don't completely understand this, but what happens if I just do that? Totally. Hey, look at that. Besides the arc being the wrong direction, it's actually working pretty well. It's a little fast also, but that's not bad. And then also we'll have to add in the momentum after you throw it. What happens if you try and throw it on one of these slimes? Nope. Can't throw it there, can't throw it there, but I should be able to throw it across. Yes. Nice. So if I go up to a slime, yes. Okay, wonderful. That was simpler than I thought to get that working. Now all we have to do is, well, let's just make sure that the Y sorting still works. Excuse me. Kind of hard to tell with this object, but that's fine. No issues so far. So the issue is in the arc calculation. So let's go down to where that happens. So current angle. It's correctly calculating, I mean, it's correctly lerping. The issue is just in the angle calculation itself. So I don't think this is a problem. I think it's up here somewhere. Maybe this isn't big enough if we did it like this. No. Am I calculating the arc center? So the arc center, carried object dot global position plus throw position divided by 2. Well, that's just taking the halfway point. But then we want to get in the perpendicular plus equals perpendicular times direction dot length, right? Because the idea here is if the when I was doing the picking up, the idea was if the object was up here, then the center is going to be somewhere like there. Right, because it's from here to here. So the center of the circle that you're creating is like this. Which means that the angle is fine. But if the object is below the player, then the circle is like this, which means that the distance going this way is bigger than the distance going this way. So it's always going to, lerp angle always takes the shortest distance, so it would go underhand. So the idea is by lowering, by getting this perpendicular vector and then lowering the arc center, you create a bigger circle so that the distance is smaller always this way, because the arc center is the overall circle that the arc is defining is larger. So theoretically, if I just make this really big, like 20, that should keep it overhand, but it doesn't. It would also make it more straight, which it does seem to be doing. The problem is that the arc center is actually being set above, it seems like. Yeah, it seems like the arc center is actually being set above both the player and the... So let's go back to this. That didn't solve anything. What was I doing here? Maybe this needs to be reversed? Oh, that does it. Okay, so that was just the flip. Because I'm traveling in the opposite direction. Okay, now that's a little bit high. So we actually do want to lower this so that it's a little bit more fluid. And let's also change the throw speed to something a bit more reasonable. Let's make it... Actually, if we make it the same, because it's traveling twice as much distance, it'll actually be twice as fast. So this speed, calling this throw speed is kind of deceptive, because it's speed, we're not taking into account distance, so the speed, it's not actually speed, it's a speed factor, but... That's the right idea. It's going very far up, which is a little strange. I don't know why it's going so far up. In fact, we could even lower that, but this is fine for now. We'll leave it the same. So what if we make this much longer? That should theoretically be a little bit straighter. We don't want this giant arc. Yeah, that's pretty good. That's pretty good. I do also need to fix the animations there, but... I think that's... I would say that's a success. Obviously needs to be tweaked a little bit, but... I can pick up, I can throw. Pick up, throw. Wow, that's a huge success. Awesome. I can't throw past the cactuses because they're a wall, which is great. I can't throw there because the space is not clear. Well, there the space should be clear. Oh, now I can't throw at all. Interesting. Somehow... Because I'm setting the Boolean, so back in the carry state, if I get the input, then I'm detecting. And then I'm checking to see if the object is wall equals false. So I need to also make sure that if Ray is not colliding, that none of these things are true. Because if we... Yeah, because if we detect something... If we try to throw and there's nothing there, these variables haven't been reset. So we need to make sure to reset them if we're not detecting anything. Oh, I don't need to do it this way. What I need to do is this. It's already here. There we go. So that should work now. Let's just test it. So can't throw here, but I can throw. Great. Oh, fantastic. Amazing. Okay, so then the next thing that needs to happen is we want to have some momentum, and this is going to be dealt with in the carry throw component. So right now it's just setting the collision layer. That's also potentially an issue with how I was resetting the collision layers, but we'll... So what we want to do is check for a bool and then add some momentum in. So let's call the bool if just thrown, and we'll create that up here. Now, if just thrown, we should probably summon a function. Well, we can just do it here because we want to be checking. If velocity dot length is what? Is less than or equal to, let's say, 0.1, then we'll make just thrown equal false. It's probably a better way to do this. Else we're just going to move and slide, and then we'll set in oh, does rigid body not take in velocity? Let's look at what rigid body has. Okay, properties. Oh, linear velocity, is that it? Linear velocity is what we want. We also want to set gravity off because we're doing So let's do that. So function ready, let's just make sure object dot we'll take gravity scale. Wait, wasn't it just a regular? Gravity scale. If linear velocity dot length, so move and slide does not Oh, actually, so we don't need to. No, we actually need to do this a little bit differently. We need to do this a little bit differently. If we make everything a rigid body when you throw it, which it should be, because once you throw it, it should really just start interacting however you want. You should be able to hit things with it, and they should be able to respond and do all that stuff. So we do want a rigid body, but the problem is we need to make sure that this doesn't. We need to like turn off the normal behavior, because right now, let's just do a little something to make that happy for now. Right now, the rock, which is our carry throw, this is a static body. Now if I change this to a rigid body, there's going to be some problems. So, oops. Extends rigid body 2D. Isn't there something besides extends that I can use? Right, because this is just a node, but I need to access these properties. I guess I just have to access them from the object. Okay, that's fine. But there's going to be an issue here, I think. Well, it doesn't seem to be actually. So what happens if I just... no, that's not what I meant to do. Okay, if just thrown, if object dot linear velocity okay, fine. Can I just do this? That needs to get more complicated than this, but huh. Why is it not responding to any kind of physics? Do I need a physics material? So physics material. We're just gonna get the bouncy friction one and see what happens there. No, see, it doesn't move at all, which is odd. It should still respond. Maybe it has to do with the collision layers. Huh. What am I doing differently here? Let's create a new resource, which would be a physics material. Let's call this no friction, just to mess around with stuff. It's going to be 0. We'll make it bouncy too. So now in the rock, let's quick load no friction. Is that the issue? No, see, it should just respond to me touching it, right? What's the issue here? The carry throw component, get parent. This is getting the rigid body. Setting the gravity scale to 0. Collision layer equals 2. Is the problem in the player? No, we should be interacting with that. Oh, interesting. Why does that happen? Curious. I do want to be able to interact with it that way. But I also want to give it some momentum. So down in here, throw, when it's done, send signal to object to respond to being thrown. So carried object, I want to access this object's linear velocity, and then I want to access this script and change this variable. So that's the two things I want to do. So number 1, carried object dot linear velocity equals locked direction times, we'll create a variable called throw momentum. Let's just make it 10 for now. Where was that now? Lock direction times throw momentum. And then we want to carried object dot get node carry throw component dot what was it? Just thrown equals true. Will that do it? No. Callable and float in operator. So we're just checking it here. So variable velocity, and in here we'll get velocity equals object dot linear velocity. No, why is that? Callable and float. Callable. So what is linear velocity? It's a vector 2. Why can I not access that? Why can I not access that? Oh, changing the 2D transform of linear velocity of a rigid body 2D very often may lead to some unpredictable behaviors. If you need to directly affect the body, prefer integrate forces. Ah. Okay. So, how do I do that? Integrate forces. So, carried object dot integrate forces. There was an underscore first, wasn't there? And what does that take in? State, physics direct body state 2D. So there's a method for the class. I'm not really getting what this integrate forces provides direct access to a physics body in the physics server 2D, allowing safe changes to physics properties. This object is passed via the direct state callback of rigid body 2D. So, rigid body integrate forces. Custom integrator property. I just want to add on a force. Is there a method? Properties, methods. Oh, we can just add force. So add, let's say apply impulse, which is what we want to do. The impulse is in a direction and a position. So in fact, I'm not sure that I need any of this. I think I don't need any of that. We can keep this really simple. So here, all we need is, we want this apply impulse. Carried object dot apply impulse, and then we need to give it an amount. So an amount in a direction. So we want locked direction times, what was it? Throw momentum. And then the position will be, I'm not sure what that position means exactly. It's the position from which the force is applied. I'm not sure if I can just do carried object dot global position. Interesting. Unexpected. Very unexpected behavior there. So what exactly is going on there? First of all, we don't want it to rotate. So let's look at that. Lock rotation. We want to set that, so we'll set that in here. Object.lock rotation equals true. So let's see what happens with this. Well, theoretically, this is kind of working. Except for that. That's a problem. Well, you know, you can't have everything. It's also happening very late. Okay, I think I'm going to have to come back to this later. I think that's a decent amount of progress so far. Oh, let me just see what happens, because I also wanted to test out this with the pool table. So if I open up the cue ball and give it the carry throw component, I'm curious what that looks like. Why can I not pick it up? Should be a carry throw. Oh, because of the collision layers. Interesting. Yeah, that's a problem. Okay, I'm gonna have to figure out all this stuff with the collision layers. Okay, but this is, I think I'm gonna end it here. Okay. I'll be back another time.